let's review the parts of a graph. I know that this is not new stuff again, but because we are going to be analyzing so much data and drawing so many graphs in this class, it's important for us to have a common set of terms and understanding so that when we speak to each other, we definitely know what the other person means. So we're going to first talk about positive slope. So positive slope might look something like that. It doesn't have to look exactly like that. It can be really anywhere on the XY coordinate system. The important part of having a positive slope is just that as your X values increase, your Y values will also increase. This is as compared to a negative slope, which again can be placed really anywhere on the XY coordinate system, but we'll keep it there for now. And the important part about a negative slope is that as your X values increase, your Y values are now going to decrease. And with a slope of 0, so maybe a line such as that, well, as our X values increase, the Y values aren't doing anything. They're just staying the same the whole time. And so for us as scientists, that really says to us that it doesn't matter what I do to X, Y is never going to change. And so there we would say that there is no relationship between these variables. If it doesn't matter what I put in for X, Y isn't ever going to change, well, then I've got just two completely unrelated things here. Let's move on and talk about positive y-intercepts. So positive y-intercept, we can have a line, and maybe it looks like this. Although it doesn't really matter. It could have a negative slope as well. But really what we want to key in on is that right there. That is a positive y-intercept. The line, ooh, I'm still writing in green. The line crosses the y-axis, above the x-axis. All right. A negative y-intercept, again, the line could have a positive slope, it could have a negative slope, maybe it's another positive sloped one. And what we want to key in on right here is that right there where we see that the line crosses the x-axis, or the y-axis, and this time it is crossing below the x-axis. All right. And then we've got a y-intercept of 0. Now, in your math class, most of the time when a y-intercept of 0 comes along, people are like, oh, cool. Goes through 0, 0, which is very important, right? We're talking about going through 0, 0 here. And many times people want to say, oh, well, if it goes through 0, 0, that means it doesn't mean anything. Well, it isn't always meaningless to have a 0 y-intercept. So we'll talk about that when we come across it in the lab itself. Why did we go through 0, 0? But one thing that I want you guys to really key in on about a 0, 0 y-intercept is that if you have, like what we've drawn right here, where we have a straight line, and it doesn't matter whether that straight line has a positive slope or a negative slope, as long as it is a straight line. And it also goes through 0, 0. It is not just a linear relationship. We give that a special name. We call that a direct proportion. I'm going to use that in a different color. We'll color it green. It's called a direct proportion. Talked about that a little bit in the last video, direct proportion. They are very important because whatever happens to x, maybe x gets doubled. If it has a direct proportional relationship to y, it means that y will also double. If x gets cut in thirds, y gets cut in thirds. And so that really helps us. Direct proportion is something that we always kind of cross our fingers for because it makes everything so easy. So here's some questions. If my data is a curve, it is not a line, can I fit a straight line to it? No! You cannot just take a curve, so maybe something like this, maybe like an x squared. You cannot take that and try to fit a straight line to it. It doesn't make any sense. Those two lines, they don't follow the same path. They're not even close to one another. So instead, what you need to do is you are going to need to modify the graph. That's what we talked about a little bit in the last lecture. We need to modify our data so that we end up getting a straight line with positive slope. So how should I do this? What should I do to modify my graph and make it a straight line? You need to replot the data, and how you will replot it depends on what the shape is. So what I would do is I would reference the graph summary sheet. That has all the different curves that we could possibly see in this class and what you need to do in order to replot the data and turn that curve into a straight line. Now we are going to do that in class most of the time using LoggerPro, but what if you're doing this at home or you're doing it during study hall and you don't have LoggerPro? Well, you can use your graphing calculator in order to do this. Okay, we are going to have a whole, like at least a half day in class where we do demos for this and we go through all the steps together and you guys get some practice doing this. But otherwise, you can watch the tutorial that's on Canvas if you forget a step or you need help. Okay, it's all within Unit 1. All the links to all the videos that you might need, it's all there. So Unit 1 is going to be pretty important. Again, this whole unit is us just trying to get all the tools that we will use for next year. So the last thing we're going to talk about is writing physics equations. Because we are doing all of this graphical analysis and we're doing all these graph modifications, we're turning curves into straight lines, I can promise you that if we ever need to write an equation from a graph, it's always going to be the equation for a straight line. It's always going to take the form of y equals mx plus b. Okay? So your graph, you cannot draw or write an equation for it until it looks something like this, where you have your y variable plotted on your y-axis, you have your x variable plotted on your x-axis, you've got the information for your slope. You have to have that, otherwise you can't write an equation. You'll have nothing to put in for m. And you need to have your y-intercept. So you see we got the y, we got the y, we got the m, we got the x, we got the b. Those are the 4 pieces of information that you're going to have to draw off of all of the graphs that you create. And you will not just substitute it right in. We're not going to do y equals mx plus b, or at least not quite. It's going to look like y equals mx plus b, but instead of writing y, I want you to write whatever you put on your y-axis. So your y variable is going to take the place of just plain old y. So maybe that variable is work, or it's energy, or it's, distance, or maybe it's time. Like whatever you put on that y-axis, that's what you're going to put there. Instead of m, you are going to write in whatever the slope is that you calculated with the appropriate units. Oh, that's a mess. Let's rewrite that one. Every single time we write a number in this class, we're always, always, always going to have a unit attached to it. So since slope is a number, we're going to have a unit with that slope. We'll multiply that slope by whatever is on your x-axis. So again, maybe that's time, maybe that's displacement, maybe it's velocity. It could be a whole bunch of things. And then finally, you will add on the y-intercept. And since a y-intercept is a number, you got to make sure that you have the unit on that number. And the unit for your y-intercept is going to be the same as the unit for your y-axis. So to kind of help you guys here, because I know that's the hardest part, is figuring out what the units are. The unit for your y-intercept is the same as your y variable. The slope, your units would be your y units divided by your x units. And that's a really easy way to figure out what units you're supposed to have on there. Again, if you do all of this within LoggerPro and you set LoggerPro up appropriately with all the units, then LoggerPro is going to give this information to you. But if maybe you're doing this as a homework problem at home, and so you're doing it on the graphing calculator, and the graphing calculator won't let you put units in there, so you have to figure out what your units are yourself. Okay, so good luck.